In this video, we are going to learn how to calculate the exact area of a graph. What is the area beneath a graph? If the graph is above the x-axis as follows, its area is given by the definite integral of the function fx from b to a, where b is your right bound and a is your left bound. On the other hand, if your graph is below the x-axis as follows, we would still get our area being equal to the definite integral of the function from b to a, but this time you need to include a negative sign in front of the definite integral. Let's have a look at an example. In this example, we are required to find the area beneath the graph of y equals to 3x squared plus 2 from x equals to 1 to x equals to 4. The first thing we need to do is to sketch the graph and shade in the relevant area. In this question, we're given the equation of y equals to 3x squared plus 2, and it is this equation that we're going to sketch the graph of. We can see that this equation is a positive quadratic graph that looks like this. We also need to sketch in the key features of this graph, which include the y-intercept at 2. And finally, do not forget to label the graph with its equation, as would help with the identification process later on in this question. Okay, the next thing we need to do is shade in the relevant area, which applies from x equals to 1 to x equals to 4. And here is how we can shade it in. Once that is done, we need to write down the definite integral that represents this area. Since this area is above the x-axis, we can write it down as the definite integral of the function 3x squared plus 2 from the right bound of 4 to the left bound of 1. And finally, we can evaluate this definite integral we have set up. To do that, we first need to anti-differentiate the function 3x squared plus 3, which will give you x cubed plus 2x. Then we need to substitute x equals to 4 and x equals to 1 into the function and find the difference between the two, so that you get 4 cubed plus 2 times 4 minus 1 cubed plus 2 times 1. This should simplify into 72 minus 3, which will give you a final answer of 69 units squared. Let's have a look at another example. Here, we are required to find the area enclosed by the graph of y equals to negative 3x squared plus 1, x equals to 3, the x-axis, and the y-axis. Again, the first thing we need to do is to sketch in the relevant graph and shade in the area. For this case, the relevant graph is y equals to negative 3x squared minus 1, which is a negative quadratic graph that looks like this. We also need to include the key features of this graph, which would be the y-intercept of negative 1. And make sure you do not forget to label this graph with its equation, as it makes identification much easier later in this question. We also need to sketch in the graph for x equals to 3, which is a vertical line at x equals to 3. Then we need to draw in the borders of this shaded area so that we know what area to shade in. We can see that the borders would include the x-axis, the y-axis, the vertical line at x equals to 3 we have just sketched in, and your graph itself. And this is the shaded area we are talking about. Now we've already shaded in the area, it is time for us to write down the definite integral for this area. Since this area is below the x-axis, we still write down the definite integral of minus 3x squared minus 1 from your right bound of 3 to your left bound of 0, but we also need to include a negative sign in front of your definite integral. Now we have set up our definite integral, it is time to evaluate it. To do so, we first need to take out the negative sign in front of your definite integral and not touch it until the final step. Then, we are ready to evaluate the definite integral itself. We can see that negative 3x squared minus 1 would anti-differentiate into negative x cubed minus x. We can then substitute x equals to 3 and x equals to 0 into the function and find the difference between the two, so that we get negative 3 cubed minus 3 minus 0 cubed minus 0. The latter would simplify into 0. We can see that negative 3 cubed minus 3 would simplify into negative 30, so that we have an area of 30 units squared. Note that if you forget to include the negative sign in front of the definite integral, you would get an area of negative 30, which doesn't make sense, as you can't have a negative area.